In this video, we're going to explore the sum and product of roots of a quadratic equation. So really this ties back to the quadratic formula, and really what the quadratic formula tells us. It tells us the two solutions or roots of any quadratic equation. The formula is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. What that really means, though, is one of my solutions is negative b plus the square root of b squared minus 4ac, all divided by 2a. And the other solution is basically the same thing, but instead of a plus the square root, it's the minus the square root. If we were to add those solutions together, something cool happens. So if we look at these two expressions right here, you'll notice that they're almost identical, but the only difference here is we have a plus versus a minus. What that means is if I start to put these together, they have the same denominator, so I can do that, is that those will cancel out. The square root of b squared minus 4ac and the negative square root of b squared minus 4ac will cancel each other out. What we're then left with is this, negative b over 2a plus negative b over 2a. When I put those together, same denominator, I can do it, I get negative 2b over 2a, which can simplify to negative b over a. So if I have a quadratic equation, and I just want to know, hey, what are the solutions added together? All I need to do then is use this little quick shortcut. The sum of the roots is this, negative b over a. When we multiply, it gets a little bit more complicated. We're going to multiply the like pieces together, and essentially we have a difference, or what we'll end up with is a difference of squares. Because if we look at the negative b, that's the same term. These are the same term but have different signs. So if I'm thinking in terms of factoring, then I know that when I factor something like x squared minus 9, it becomes x plus 3 and x minus 3. Same idea to get this little shortcut formula we have. We're going to square the negative b, and we're going to square the square root of b squared minus 4ac. When we square a negative b, that becomes a b squared. When we square this, the square roots are going to cancel out. B squared minus 4ac. Then I take b squared minus the quantity, which will cancel the b squareds out. That's cool. And then I have a negative negative, so back-to-back negatives, of 4ac, all divided by 4a squared. The 4's cancel. One of the a's cancel from the top and the bottom, and we're left with c. So the product of the roots turns out to be c over a. So how do we apply this? Well, again, here's our little shortcut formula. Sum of the roots is this. Product of the roots is that. In a question like number 1 and 2 are going to find the sum and the product of this formula. What we need to do first is make sure that we have it in the form where everything's on one side, just like factoring, and just like discriminant, and just like the quadratic formula. So we're going to bring x squared over. We're going to add 6x, and we're going to add 3. So we have 2x squared plus 8x plus 8 equals 0. Number 1 asks for the sum of the roots, so I need to find negative b over a. Well, let's find a, b, and c. A is 2, b is 8, and c is 8. So the sum of the roots is the opposite of 8 over a, which would give us negative 4. The product of the roots is c over a, so it's just going to be 8 divided by 2, positive 4. Now, the toughest part of these questions, I think, is reading them to understand what is it asking us to actually do. So on a question like number 3, when we have the sum of the roots, or if the sum of the roots is m and the product of the roots is n, it's a little bit challenging about this is we have to find out what the sum is, and then what the product is, and then go ahead and plug them in. So we can do that, finding a, b, and c, because it's already equal to 0, so we're good to go on that. The sum of the roots, so this is going to be our m value, is equal to negative b over a. So the opposite of negative 6 is 6. over a, which is 6. The product is going to be c over a, 7 over 1. What we're asked to find is 2 times the product of those. So that's 84. On a question like number 4, we're kind of working backwards. So on this, what we're asked to do is find the equation. They're telling us what the sum is. They're telling us what the product is. We want to know what's a quadratic equation that could meet those criteria. So the sum we know is negative b over a, and that equals negative 4. We have c over a, which equals 9. Now, if you look at those two numbers, what's significant about those is they're both whole numbers. So I could, if I wanted to, and I think I do, I want to write that negative 4 is negative 4 over 1, and the 9 is 9 over 1. What that tells me then is that a is 1. If the opposite of b is negative 4, then b is 4. And if we have that fraction, then c has to equal 9. So one equation I could have is x squared plus 4x plus 9 equals 0. And then one more, number 5. If the roots of this equation are c and d, find the value of 3 times c plus d. Well, this part right here is identifying sum of roots. We're going to find out what the sum of the roots is, and then we're going to multiply that by 3. Well, the sum of the roots is just negative b, which in this case would be negative 8, over a, which is 5. Then we're going to take, sorry about that, we had some technical difficulties and OneNote just crashed on me. We're going to take c plus d, which is the sum of the roots, which we found was negative b over a, so negative 8 over 5. And then we're supposed to take 3 times that. So if we do 3 times negative 8 over 5, we get negative 24 over 5. Again, the sum of the roots is negative b over a. Product of the roots is c over a. If it's set up in the form ax squared plus bx plus c equals 0. The trick is read the last part of that question and figure out what is it asking us to actually do.